Hello, everybody. Am I audible? Yes. Saint Joseph. New PU, I got to know Saint Joseph. Am I audible? Yeah, okay. Nippon. Yes, thank you. Nippani also, right? I am audible? Okay. Uh, Today, I have a list of students who have scored well in the recent CET test. Okay. I'm just gonna call out their name, a few names. Do we have Swarali Kulkarni from Nippani? Can you raise your hand? Just raise your hand. Don't worry, I'm not going to ask you any question, okay? From which Nippani class? I don't know. Swarali Kulkarni. No? Is she absent? Does she belong to your class? 20. Okay. She's absent today? Okay, fine. Shruti Patil? Okay, fine. Fine, fine. Shruti Patil? Who is Shruti Patil? Okay, good, very good, very good. And Sanika Mali? Sanika? Okay, sit down. Sujal? Sujal? Who is Sujal? From which class? Okay, very good, Sujal, yes. And Prithviraj? From which class? I don't know. Prithviraj. Fine. Priya? Priya Hanchanale? Priya? Okay, okay. So very good. Ritesh, another one. Ritesh. Who is Ritesh? Okay, fine. So very good Nippani students. I see many names. Many of you have scored very well. Keep it up. Next, coming to New PU Raibag. Rihan? Who is Rihan? Okay. Yes, very good Rihan. Sneha from New PU. Okay, very good. I got to know. Rohini? Rohini, fine. So very good, New PU Raibag. Keep it up, okay? And you know why am I doing all these things? I want other students also get inspired by this. I want more number of these students. Andre, ಈ ಟಾಪ್ ಲೆವೆಲಲ್ಲಿ ತುಂಬ ನಂಬರ್ ಬರಬೇಕು ಬಿಕಾಸ್ ನಾನು ಯಾವಾಗಲೂ ಹೇಳೋದು ಒಂದೇ ಒಂದು ಓನ್ಲಿ ಒನ್ ಥಿಂಗ್ ಐ ಜನರಲಿ ಕೀಪ್ ಟೆಲ್ಲಿಂಗ್ ಆಫ್ ಆಲ್ ದಿ ಸಬ್ಜೆಕ್ಟ್ very easily scoring subject is chemistry. If you take PCM, chemistry is the easy scoring subject. So topping in chemistry should not be very difficult for you people. Same kind of questions, repetitive kind of questions are very common. Okay, yes, next one more. We have, I think, Raibag also. Is Preeti Santosh Patil from Raibag? Do we have her? From which class? Okay, very good Preeti. Yes, first bench alla idira. Srushti Basavaraj? Srushti, very good Srushti. Yes, I can see sitting in first bench is working. Very good. Okay, next. Anam Maula. Maybe nan pronunciation wrong irbodu. Pardon me. Okay, Anam. Okay, very good. Yes. Tanuja Patil. Tanuja Patil. Okay. Ashwini, very good. Ashwini, yes. Mamatashri, rhyming with my name, Mamatashri. Where do we have? Okay, Mamatashri, absent. Maya Sadashiv. Raise your hands properly, students. I am not able to find you in this. We have very okay tiny ants tara kaantirtira kelomme. Okay, Maya Sadashiv and Vaishnavi. Vaishnavi. Okay, good. I think one more. No, I have taken. Srushti, I think I have taken, right? Srushti. Name. Okay. Yes. So these are toppers list that I have, and many more of you. I want your names to be here. Okay. So keep it up. Those whose names I have taken, keep it up, and everybody else, I want you to study more hard. Okay, so with this we shall start our session. We were discussing electrochemistry and we were discussing specific conductivity, molar conductivity, right? We'll continue with that. Later we'll discuss other part of this Faraday's law of electrolysis and all. We should start with this easy question. I want very quick answer. I want poll result. Very quick answer. Because this is simple question. Option C. Okay. Option A. 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 Okay. Good. You're answering quickly. Along with that, I should get this answer also. Fine. One thing which we can easily relate is this, alva, EMF 2 volt. So we have 2 related to D in 2 option, that is A and C, B and D eliminated, alva, 2 related to D, EMF volts. Now, this specific conductivity, how do we take this? 1 by R into L by A, alva? 1 by R anta andre 1 by ohm, L andre centimeter, A is area which is centimeter square. Centimeter gets cancelled. We get centimeter in the denominator. We shall take that to the numerator. We'll get centimeter inverse, and ohm also, if you take that to the numerator, you'll get ohm inverse. Ohm inverse is nothing but Simon, alva? Simon centimeter inverse. So this is 3 should be related to A. Ayyo. 3 is related to A. Where do we have that? 3A, 2D. But in option C, 3 is related to C, it is cancelled. Option A is the correct one. Okay? 3 is related to A. Option A is the correct answer. Fine. We'll go to next question quickly. Yes. This is a very good question, and this question is based on a concept, Kohlrausch law. Alva, Kohlrausch law ಏನು ಹೇಳುತ್ತೆ? If you want to find out molar conductance of a salt or any species, A, B ಅಂತ ತಗೊಂಡ್ರೆ, it will be equal to sum of the conductance of the cation and anion. Cation ಮತ್ತೆ anion conductance ನ sum ಇರುತ್ತೆ. Alva, using this Kohlrausch law, you should answer this question. Look, they have given molar conductance value, but here they're asking you equivalent conductance. Don't get confused. In this case, propanoic acid case, equivalent conductance is equal to molar conductance. Why? How do you find out equivalent conductance? Equivalent conductance is n factor into molar conductance. n factor anta andre enu? ಎಷ್ಟು electrons involve ಆಗಿದೆ? In C2H5COOH, how do you break this? C2H5COO minus and H plus, alva? ಇಲ್ಲಿ ಎಷ್ಟು electron involvement ಇದೆ? 1 electron involvement. So n factor is 1. So that's why equivalent conductance will be equal to molar conductance. So ನೀವು molar conductance find out ಮಾಡಿ. That will be equal to equivalent conductance. How do you find out molar conductance? That is something you have to work out. Find out and tell me. Here actually they have given the option in molar conductance only. Unit nodidre gottagatte. So find out molar conductance only. No confusion. So application of Kohlrausch law. B. Okay. D. Poll result. Okay, B, most of you are going with, okay. Nodi, I have to find out molar conductance of C2H5COOH. That means the molar conductance of this propanoic acid, it will be sum of molar conductance of the anion, that is this anion, and the cation, that is H plus. If I somehow find out the value of this part, I'll be able to get the molar conductance of this. Now how do I do this? I'll do this using this expression. Hege, nodi, I'll take molar conductance of C2H5COONA and I'll add molar conductance of HCl and I subtract molar conductance of NaCl from this. Why am I doing this? Look, again application of Kohlrausch law. To find out the molar conductance of this salt, it is nothing but, it is the sum of, it is the sum of molar conductance of ions. You know, C2H5COO minus plus molar conductance of Na plus. Again, molar conductance of H plus andre eno, it is the sum of conductance of H plus and conductance of Cl minus. Minus of molar conductance of NaCl andre Na plus ಮತ್ತು Cl minus in a sum. Now when you write like this, you can do one thing. Nodili, this Na plus, positive Na plus minus Na plus cancel ಆಯಿತು. Positive Cl minus negative, this is plus into minus negative alva, negative Cl minus. These two conductivities gets cancelled. Now what do you end up with? You end up with this conductivity of this anion, conductivity of this cation, H plus and C2H5COO minus alva. When do I, look, this is what I have to find out nodi. Ide nan find out, erase agoyta. Ide nan find out ಮಾಡಬೇಕಾಗಿತ್ತು. This is what I had to find out. Alva? Nan adanne il ತಗೊಂಡು ಬರ್ತಾ ಇದೀನಿ. By doing this thing. If I take this one, I'll be able to get this factor. Anion and cation ka sum. Alva? ಇವಾಗ ನಾನು ಏನು ಮಾಡ್ತೀನಿ? One thing is confirmed. If I do this, I'll be able to get this andre. I'll find out the value of this one. ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ಇದು? ಅಯ್ಯೊಂದು 91 conductivity of this and conductivity of HCl ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? 426.16 minus what is the conductivity of sodium chloride? 126.45. Alva? Calculate this. How much do you get? Do you get option B, 390.71? Everybody? Yes, you'll get 390.71. Alva? Nan hegadru I want to get at this point. Nanige ee sum barbeku. Ee sum yaudrinda barbeku using the given value. They have given conductivities of these three. Using these three, I'll end up getting this one. Adu hige. Okay? Option B is the correct one. So this is the application of Kohlrausch law. Okay? Yes, option B is the correct answer. Next, we'll go to this one. Conductance at infinite dilution of these salts. So, very good question this is. Theory apply ಮಾಡಬೇಕು. ಏನು theory apply ಮಾಡ್ತೀರಾ ನೋಡೋಣ. I need poll result first. So most of you are going with option C. Oh, I don't see this ಹೇಗೆ ಅಂತ ಹೇಗೆ ಹೇಳ್ಬೋದು how can we find out this I will relate this to a concept that we studied in D and F block elements. Okay, one thing you remember, if we have to improve the conductance increases as speed of ion increases. Okay, speed of ion is directly proportional to hydrated radius. ಏನಿದು hydrated radius? ನೋಡಿ, here we have 3 salt and anion is same. Everywhere we have chloride, but the difference is in cation. We have lithium plus, sodium plus and potassium plus. So we are moving down the group. Down the group, what happens to size? Does it increase or decrease? Can you tell me? Increase. Down the group, the size of ions or atom, it increases. So now if I have to write the size of the ion order, lithium less sodium then potassium. Okay, potassium ion is having a larger size. But if I have to write the hydrated size, the order is ulta. Lithium more, sodium more, potassium very less. Why is that? Nodi, I will take lithium ion in water and sodium, potassium in different beaker anta tagoli. Now, when you dissolve these ions in water, what will happen? The water molecule, the negative charge of oxygen in water molecule, it will get attracted towards the positive cation. It will get attracted towards the positive cation. If the cation size is very small, if size of cation is less, then more water molecules will get attracted. More water molecules will get attracted towards this cation. Now, of these 3 cation, lithium has very, very small size. So that means more number of water molecules will surround this lithium ion. Alva? Ega, if I compare this with the potassium ion is having a larger size. Larger size ide antandre very less number of water molecule. Very less number of water molecules will get attracted towards this positive cation. ಆಯ್ತಾ? ಈಗ ನಾನು ಏನಕ್ಕೆ ಹೀಗೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಹೈಡ್ರೇಟೆಡ್ ರೇಡಿಯಸ್ ಜಾಸ್ತಿ ಇದ್ದರೆ, ನಾನು ಏನಂತ ಹೇಳಿದೆ, ಹೈಡ್ರೇಟೆಡ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರೊಪೋರ್ಷನಲ್, ಸಾರಿ ಇಟ್ ಇಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರೊಪೋರ್ಷನಲ್. ಇದನ್ನು ಇನ್ವರ್ಸ್ಲಿ ಪ್ರೊಪೋರ್ಷನಲ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡಿ. ಇನ್ವರ್ಸ್ಲಿ ಪ್ರೊಪೋರ್ಷನಲ್ 1 by hydrated radius. Sorry, please make this change. In the flow, I just missed this point. Speed is inversely proportional to hydrated radius. ಯಾಕೆ ಹಾಗೆ ನೋಡಿ, ವೆರಿ ಕಾಮನ್ ಸೆನ್ಸ್ ಥರನೇ ಅಪ್ಲೈ ಮಾಡೋಣ. ಜನರಲ್ ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳೋಣ ಆಯಿತಾ. ಈಗ ಏನು ಆಗಿದೆ ಪ್ರಾಬ್ಲಮ್, lithium is a very small cation. It is surrounded by many water molecules. Okay, if it is surrounded by many water molecules, the hydrated radius is more. ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಜಾಸ್ತಿ ಸರೌಂಡ್ ಆದರೆ ಹೈಡ್ರೇಟೆಡ್ ರೇಡಿಯಸ್, ಅದನ್ನೇ ಹೈಡ್ರೇಟೆಡ್ ರೇಡಿಯಸ್ ಅಂತ ತಗೊತಾರೆ ಈ ರೀತಿ. ಓಕೆ, ದಿಸ್ ಪಾರ್ಟ್ ಇಟ್ ಈಸ್ ಮೋರ್. ಈಗ ಹೈಡ್ರೇಟೆಡ್ ರೇಡಿಯಸ್ ಜಾಸ್ತಿ ಆದರೆ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತಾ ಇದೆ ನೋಡಿ. ಫಾರ್ lithium ion to conduct what it should do, it should move towards the electrode in a higher speed, with a greater speed ಅಲ್ವಾ. ಈಗ ಏನಾಗ್ತದೆ, lithium ion is surrounded by many water molecules. Now if it wants to go towards the electrode, it should push all the water molecule aside and then it has to move towards the electrode alva. This is the problem now. Water molecule surrounding the lithium ion has become a hindrance. Just simple example tagoli. If I want to move from this point to that point, I can move very swiftly. Aram se I can move. Now let us imagine I am standing here, I am surrounded by many people. Now moving towards that point has become a problem because I have to push aside all the people, then I have to move towards that point. Alva? In ನಂಗೆ difficult ಆಯಿತು. ಅಂದರೆ having water molecule is a hindrance for the speed. ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಇರೋದ್ರಿಂದ ಸ್ಪೀಡ್ ಆಫ್ ದಿ ಕ್ಯಾಟಿಯೋನ್ ಏನಾಗ್ಬಿಡ್ತು, ಲೋ ಆಯಿತು. ತುಂಬ ಕ್ವಿಕ್ಕಾಗಿ ಅದು ಎಲೆಕ್ಟ್ರೋಡ್ ಕಡೆ ಮೂವ್ ಆಗೋಕ್ಕಾಗ್ತಾ ಇಲ್ಲ. ಸ್ಪೀಡ್ ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ ಅಂದರೆ ಏನಾಗ್ತಾ ಇದೆ, ಇಫ್ ಸ್ಪೀಡ್ ಇಸ್ ಡಿಕ್ರೀಸಿಂಗ್, ದಿ ಕಂಡಕ್ಟೆನ್ಸ್ ಇಸ್ ಆಲ್ಸೋ ಡಿಕ್ರೀಸಿಂಗ್. ವೈ ದಿ ಸ್ಪೀಡ್ ಇಸ್ ಡಿಕ್ರೀಸಿಂಗ್? ಬಿಕಾಸ್ lithium is surrounded by many water molecule. Okay, now if I compare this with the potassium, potassium को तो ये बहुत आराम है. Why? Potassium is surrounded by very few water molecules. Allo illo ibru water molecule idare. It can push aside those water molecule very easily and it can move towards the electrode quickly. So that's why the conductivity increases in case of potassium ion. Why? Potassium ion has got very small hydrated radius. As hydrated radius decreases, the conductivity increases. So option B is the correct answer. Nodi, hydrated radius order ಏನಾಯಿತು ಇದಲ್ವಾ? This is the hydrated radius order. Lithium is having more hydrated radius. So its conductivity should be less. Nan conductivity order if I have to write, ಅದೇನಾಗತ್ತೆ? Potassium more, then sodium, least is lithium. Okay, more the hydrated radius. E point, this is very important. Okay, idundu nimage nenpidre, if you can remember this kind of question. Look, this is a very good question. It generally ella riti competitive allu have seen this kind of question. Okay, yaake nan hydrated radius tagonta idini, that is also important. Look, here we have taken these salts in solution alva, infinite dilution andre solution ಮಾಡಿದ್ದೀವಿ. We have dissolved those in water. ಹಾಗಾಗಿ ನಂಗೆ hydrated radius matters. This is the important part. Rather than size, hydrated size is the important part. Okay, option B. I hope you understood this. Option B is the correct one. So last one question based on this concept is this. This is a previous year question. ವೆರಿ ಸಿಂಪಲ್ ಕ್ವೆಶನ್ ನೋಡಿ, ಹಾಗೆ ಆನ್ಸರ್ ಮಾಡ್ಬೋದು. ಬಿ. ಹಾಂ, ವೆರಿ ಗುಡ್. ಎಸ್, ಆಪ್ಷನ್ ಬಿ ಇಸ್ ದಿ ಕರೆಕ್ಟ್ ಆನ್ಸರ್, ರೈಟ್? ಕಂಡಕ್ಟಿವಿಟಿ ನೀವು ತಗೊಂಡ್ರೆ ಇಟ್ ಇಸ್ ಕೆ ಇಂಟು 1000 ಬೈ ಸಿ. ಸೊ ಆ್ಯಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇನ್ಕ್ರೀಸಸ್, ದಿ ಕಂಡಕ್ಟಿವಿಟಿ decreases, molar conductivity decreases, it is inversely proportional. So here we have a very less concentration, so the conductivity of the solution is very high. Very good, option B is the correct. That was very quick. Good. Now we will be moving towards the next part of this electrochemistry series, that is the Faraday's law. Alva, ee Faraday's law alli you will come across only two kinds of question and we will be discussing those only. Faraday's laws alli we have two law alva. First law, simply if I have to put the first law ಏನಂತ ಹೇಳುತ್ತೆ? The amount of chemical reaction, why is this working like this? Amount of chemical reaction happening at a particular electrode, it is dependent on what? It is dependent on amount of electricity that we are passing. ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ವಿ ಆರ್ ಪಾಸಿಂಗ್ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಇದು ಯಾರು ಹೇಳ್ತಾರೆ? ಫಸ್ಟ್ ಲಾ ಹೇಳ್ತಾರೆ. ಸೆಕೆಂಡ್ ಲಾ ಏನು ಹೇಳುತ್ತೆ? ಸಿಂಪಲ್ ಆಗಿ ಇಫ್ ವಿ ಹ್ಯಾವ್ ಟು ಪುಟ್ ಸೆಕೆಂಡ್ ಲಾ, ಸೊ ಇಫ್ ವಿ ಆರ್ ಪಾಸಿಂಗ್ ಸೇಮ್ ಅಮೌಂಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ to two different solution having two different kind of electrode, ಆವಾಗ ಅದು ಯಾವ್ದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ? ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ ಹ್ಯಾಸ್ ಬಿನ್ ಫಾರ್ಮ್ಡ್. ಹೇಗೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ? ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದಿ ಈಕ್ವಿವೆಲೆಂಟ್ ವೇಟ್. equivalent. It is directly proportional to the equivalent weight. ಇದೆಲ್ಲ ನಮ್ಮ ಸ್ಟ್ಯಾಂಡರ್ಡ್ what do you say the law statements and all. But for us in KCET ನಮಗೆ ಏನು ಬೇಕಾಗತ್ತೆ, we have to solve problems. ಆ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವಿಂಗಿಗೆ we need formula ಅಲ್ವಾ. So this is the formula that we are going to use in this part. Kindly note down this, where I is current, T is time, W is the molecular weight or atomic weight, and Z is equivalent. Okay, so equivalent weight you will find out. So we will use this expression now and find out answers to few questions. Done alva? ಎಲ್ಲ ಕಾಪಿ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ? ZIT by 96500. Now we'll start with a very simple question. Yeah, this one. Charge required for reducing 1 mole of permanganate to Mn2 plus. So 1 mole electron is equal to 1 Faraday. Remember this. Option D. D. Okay. Option D. Option D. Okay. हाँ हाँ निप्पाणी students, the Rayabog students, everybody, cue card answer. I need that analysis students. Everybody should answer. ಸುಮ್ಮನೆ ಕೂತ್ಕೊಳ್ಳೋದಲ್ಲ. Few students will answer orally, will just listen to the class. No, that doesn't work. Everybody should involve. Yes. ಹೇಗೆ MnO4 minus 2Mn2 plus ಅಲ್ವಾ. ಈಗ what is the oxidation state of manganese over here? Very good. +7 to +2 ಅಂದರೆ ಎಷ್ಟು ಮೋಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಲ್ವಾ? 5 ಮೋಲ್ ಎಲೆಕ್ಟ್ರಾನ್. ನೋಡಿ 1 ಮೋಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂದರೆ 1 ಫ್ಯಾರಡೆ. 5 ಅಂತ ಅಂದರೆ ಎಷ್ಟು? 5 ಫ್ಯಾರಡೆ ಅಲ್ವಾ. ಫ್ಯಾರಡೆ ಅಂದರೆ 96500 ಅಲ್ವಾ. 5 into 96500. How much you get? Yes, option D, 4825. So you have to convert, ನಿಮಗೆ ಎಷ್ಟೋ thousands ಅಲ್ಲಿ ಎಷ್ಟೋ ಬರುತ್ತೆ, you have to convert that into 10 power 5. Okay, so option D is the correct answer. Very good. Most of you have answered option D only. ಇದಾದ್ಮೇಲೆ ಇನ್ನೊಂದು ಕ್ವೆಶನ್. Three F. Huh. 3F alva. But we don't have that option alva. Options are wrong. Grays. So this is a previous year question actually. ಏನಾಗ್ತದೆ, ಏನು ತಪ್ಪು ಮಾಡ್ತಿದ್ದೀರಾ? ಇಲ್ಲ, ತಪ್ಪು ಆ್ಯಕ್ಚುಲಿ ಮಾಡಿಲ್ಲ. ಯು ಹ್ಯಾವ್ ಆನ್ಸರ್ಡ್ ಕರೆಕ್ಟ್ಲಿ, ಬಟ್ ಒನ್ ಥಿಂಗ್ ಯು ಆರ್ ಮಿಸ್ಸಿಂಗ್. ಆಪ್ಷನ್ ಸಿ. ಓಕೆ, 6 Faraday. हाँ, ನೋಡಿ, first of all we'll do, every time we have to do one thing, we have to find out the oxidation state of chromium. Can you tell me oxidation state of chromium? +6. Very good. So we see the change in +6 to +3. That means 3 Faraday is required for this. But ಇಲ್ಲಿ ಏನಾಗ್ತದೆ, +6 will be the oxidation state of 1 chromium. 1 chromium ಅಲ್ವಾ? ಇಲ್ಲಿ ನಮಗೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿ 2 chromium atom ಇದೆ. ಹಾಗಾದ್ರೆ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ should also have 2 chromium atom. You have to multiply that. Recollect the concept that you studied in first year redox reaction, balancing redox reaction. This is what you used to do. Left hand side, right hand side atoms ಅನ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕಲ್ಲ ಫಸ್ಟ್ ಸ್ಟೆಪ್ಪಲ್ಲಿ, ಅದನ್ನು ಮಾಡಬೇಕು. ನೋಡಿ, 1 ಕ್ರೋಮಿಯಮ್ಗೆ ನಮಗೆ 3 ಫ್ಯಾರಡೆ ಬೇಕಾಗ್ತದೆ. 2 ಕ್ರೋಮಿಯಮ್ಗೆ ವಿ ರಿಕ್ವೈರ್ ಹೌ ಮಚ್? 2 ಇಂಟು 3 ಫ್ಯಾರಡೆ. ಸೊ ಹಾಗಾಗಿ ಎಷ್ಟು ಬರುತ್ತೆ? 6 ಫ್ಯಾರಡೆ. 6 ಫ್ಯಾರಡೆ. ಸೊ ಆಪ್ಷನ್ ಸಿ. ಅದನ್ನು ಮಿಸ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಇಲ್ಲಿ ನೀವು ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ವೆನ್ ಯುವರ್ ರೈಟಿಂಗ್, ದಟ್ ಇಸ್ ಫಾರ್ 1 chromium, ನಾಟ್ ಫಾರ್ ಬೋತ್ ದಿ ಕ್ರೋಮಿಯಂ. ಸೊ 1 chromium to 1 chromium 3 ಫ್ಯಾರಡೆ ಎಲೆಕ್ಟ್ರಾನ್. ಇನ್ನೊಂದು ಕ್ರೋಮಿಯಂ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ 6 ಫ್ಯಾರಡೆ. ಓಕೆ, ಆಪ್ಷನ್ ಸಿ. Since this was PYQ, that's why I have taken. So I have one more PYQ for you, similar kind of question. But it's quite lengthy if you see. ನೋಡಿ ಏನು ಮಾಡ್ತೀರಾ ಅಂತ. B. हाँ. Others? I'm actually giving you more time. Tumba simple ide. You shouldn't be taking this much time. Option A. Ha, poll result. Option C. Ha. Poll result. Others. This is the stoichiometric equation that they have given us. Like we have to use this and find out the answer. So NaClO3 we have. Chlorine का oxidation क्या है इसमें? What is the oxidation state of chlorine? +5. Very good. So we have +5 oxidation state over here. 3 na. Is it? 4 into -2 -8 +1 -7. ikkade hodre +7. So it is +7 alva. Chlorine +5 to +7 anta andre in this reaction we see 2 Faraday electricity required alva. 2 Faraday electricity required. Now 2 Faraday electricity if I pass, I am getting 1 mole of NaClO4, right? 1 mole NaClO4. This is according to the equation that they have given, stoichiometric equation. Now they are asking, if we pass 3 Faraday, then how many moles of NaClO4 we will get? Simple, cross multiply, in baratte 3 into 1 mole by 3 Faraday divided by 2. ಎಷ್ಟು ಬರುತ್ತೆ? 3/2 ಅಂದರೆ ಎಷ್ಟು? 1.5 mole. Very good. Somebody answered option C. Option C is the correct one. Simple calculation, cross multiplication. So ಅದಕ್ಕೆ ಅವರು ಈ ಈಕ್ವೇಷನ್ ಕೊಟ್ಟಿರೋದು. ಈ ಈಕ್ವೇಷನ್ ಎಷ್ಟು ಮೋಲ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗಿದೆ? Find out the oxidation state, you'll get to know. Alva? So that is how it is. Option C is the correct answer. Hmm. We'll discuss this one. I will help you with this question. Last part calculation, you do and tell me the answer. Okay, I need answer using cue cards for it. I will help you with this question. So for this question, when they're asking some hours and all, obviously we have to use that formula that I had given you. Yeah, formula ittu nam hatra. W is equal to ZIT divided by 96500. So we will take this formula in terms of time. W into this divided by Z into I. Now, T is equal to W means molar mass. ಇವಾಗ ನಾವು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ವಿ ಆರ್ ಪಾಸಿಂಗ್ ಅ ಕರೆಂಟ್ ಆಫ್ 3 ಆಂಪಿಯರ್ ಆ್ಯಂಡ್ ವಿ ಆರ್ ಟ್ರೈಯಿಂಗ್ ಟು ಡಿಕಂಪೋಸ್ ವಾಟರ್ 1 mole of water electrolytically. ಹಾಗಾದರೆ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಮೋಲಾರ್ ಮಾಸ್ ಆಫ್ ವಾಟರ್. ವಾಟ್ ಇಸ್ ದ ಮೋಲಾರ್ ಮಾಸ್ ಆಫ್ ವಾಟರ್? 18. Very good. So this W is 18 into 96500 divided by I is current, which is 3. And we have to find out Z, which is the equivalent mass. Now Z is molecular weight or molecular mass by n factor. ಆಯ್ತಾ? Molecular weight ಎಷ್ಟಿದೆ ವಾಟರ್ದು? 18. n factor find out ಮಾಡಬೇಕು. How do we find out n factor? We find out that using the reaction that is happening. We are electrolyzing water. ಅಲ್ವಾ? ವಾಟರನ್ನು ಎಲೆಕ್ಟ್ರೋಲೈಸ್ ಮಾಡಿದಾಗ ವಿ ವಿಲ್ ಗೆಟ್ ಹೈಡ್ರೋಜನ್ ಆ್ಯಂಡ್ ಆಕ್ಸಿಜನ್. ಆಯಿತಾ? ಇಲ್ಲಿ ಏನು ರಿಯಾಕ್ಷನ್ ನಡೀತಾ ಇದೆ? ವಿ ಶಿಲ್ ಸಿ ದ್ಯಾಟ್. ಲುಕ್, ಇನ್ ದಿ ರಿಯಾಕ್ಟಿಂಗ್ ಪಾರ್ಟ್ ವಿ ಹ್ಯಾವ್ ಹೈಡ್ರೋಜನ್ ಇನ್ ವಾಟ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್. ಹೌ ಡು ಯು ರೈಟ್ ದಿಸ್ H2O? 2H+ ಅಲ್ವಾ? 2H+ ಇರುತ್ತೆ. 2H+ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟಲ್ಲಿ ಇರುತ್ತೆ. Now this 2H+, it is converting into what? It is converting into H2. ಆಯಿತಾ? ಈಗ ನೋಡಿ, ಇಲ್ಲಿ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಕನ್ವರ್ಷನ್ ಏನಾಗ್ತದೆ? ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇಸ್ 0 ಫಾರ್ H2. ಇಲ್ಲೇನಿದೆ? +1. +1 to 0 ಬರಬೇಕು ಅಂದರೆ I have to give electron ಅಲ್ವಾ? This is what process? This is reduction process. I have to give electron. +1 ಇಂದ 0ಗೆ ಬರಬೇಕು ಅಂದರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಡಬೇಕು? 1 electron. I have to give 1 electron. So ಒಂದು H+ಗೆ 1 electron ಕೊಡಬೇಕು. 2H+ ಇದ್ರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಡಬೇಕು? 2H+ requires 2 electron. ಆಯಿತಾ? 2H+ requires 2 electron. So ಇಲ್ಲಿ electron involved ಎಷ್ಟು? 2 electron. If I supply 2 electron, then I can convert 2 proton into hydrogen molecule. Again, another part of the reaction we shall see. Here oxygen in the water part, it is in -2 oxidation state. Oxygen is in -2 oxidation state. And I am converting that O2 minus into O2. O2 ಅಂತ ಅಂದರೆ ಇವಾಗ ಯಾವ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟಲ್ಲಿದೆ? ಇಟ್ ಈಸ್ ಇನ್ 0. -2 to 0 ಅಂತ ಅಂದರೆ -2 ಮೀನ್ಸ್ ಇಟ್ ಹ್ಯಾಡ್ 2 extra electron. ಇವಾಗ ಏನಾಯಿತು? ವಿ ಹ್ಯಾವ್ ರಿಮೂವ್ ದಟ್ 2 electron ಆ್ಯಂಡ್ ಕನ್ವರ್ಟೆಡ್ ದಟ್ ಟು 0. ರಿಮೂವಿಂಗ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂದರೆ ಯಾವ ಪ್ರೋಸೆಸ್? ಆಕ್ಸಿಡೇಷನ್ ಪ್ರೋಸೆಸ್ ಅಲ್ವಾ? ಸೊ 2 electron ಹೊರಗಡೆ ಬರ್ತಾ ಇದೆ. ಸೊ ದ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್, ಇಲ್ಲಿ 2 electron ಬರ್ತಿದೆ, ಇಲ್ಲೂ ಸಹ ಏನಾಗ್ತದೆ? 2 electron. ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ ಇನ್ವಾಲ್ವ್ ಆಗಿದೆ ಇನ್ ದಿಸ್ ಎಲೆಕ್ಟ್ರೋಲಿಸಿಸ್ ಪ್ರೋಸೆಸ್? 2 electron. ಇಲ್ಲಿಂದ ಏನು ಎಲೆಕ್ಟ್ರಾನ್ ಬಂದಿದೆ ಅಲ್ಲ, 2 electron that has been removed from this process, that 2 electron will be utilized in this process. So the n factor is nothing but these electrons which are involved. N factor, from this I will get to know n factor is 2. Okay, I will use this n factor value over here. 18 by 2 ಏನಾಯಿತು? 9. ಆಯಿತಾ? We will put that z value over here. 9 ones are, 9 twos are. Calculate this value and tell me this value. 2 into 96,500 divided by 3. ಎಷ್ಟು ಬರ್ತಿದೆ? You will not get direct answer. Don't go for that. You tell me the value. Some 6,400 something are you getting? I calculated this before coming to the class. Everybody should try. I see Nippani class number 19 first bench girl. Open your book and try. You're seeing here and there. Yes, can you tell me the approximate value, everybody? Anybody? Yes? 6? 353 something, alva? So this is 333. Okay. 333, na? Aitu. Okay, fine, 0.33. So this, whatever value you are getting, that is in second, but they're asking us in hour, alva? Now, you know this, 1 hour is 3600 second. We have this many second. What is the hour? Alva? Cross multiply and answer using cue card. I need poll result for this simple calculation. Very simple this thing. Yes, everybody, Raibach students, boys to the left. Third bench, 2 boys. Open your book. Those 2 boys, yes. Simply sitting, the other one also. Start solving. ಎಷ್ಟು ಬರುತ್ತೆ? How much do you get? Option C, yes. You will get approximately some 17.8 or 9, alva? You have to approximate it to option C. Okay? Round off madbidi aita. Option C, 18 hours. This is how you calculate. So, what do we need in this question? Obviously, you have to remember the formula which should be used. Along with that, this kind, in factor finding out. That is one important point. Okay? Hege anta. Yes, I hope you understood. We'll go to next question. Yes, this one. Now, in the question, assume that you are given this data also. Atomic weight of silver 108 and atomic weight of aluminium 27. Okay, gram per mole. No space to write unit, but yes, these are the values. Now try. You don't have to use any formula for this, I'm telling you. You don't have to use any formula. There is a simple way to do this. Try. So this is related to that second law. No? Nobody has idea how to answer this? Option, very few of you have answered, you're going with option C. But no. The technique is very simple. Look, they're asking 54 gram of silver will deposit. No, if 54 gram of silver is deposited during an electrolysis, how much aluminum will be deposited by the same amount of electric current? ಈಗ silver, if it is getting deposited, silver deposit ಆಗ್ತಿದೆ ಅಂದರೆ ರಿಡಕ್ಷನ್ ಆಗುತ್ತೆ ಅಲ್ವಾ, Ag plus will get converted into Ag. ಸೊ +1 to 0 ಅಂತ ಅಂದರೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಯೂಸ್ ಆಗಿದೆ? 1 ಫ್ಯಾರಡೆ ಅಲ್ವಾ. 1 Faraday electricity is used to deposit 1 mole of Ag. 1 mole of Ag is equal to atomic mass of Ag. That is what they have given, 108. Alva? Hagadre 1 Faraday is used, 1 Faraday of electricity, it is utilized to deposit 108 gram of Ag, silver. But illi, in our question, they are saying they are depositing 54 gram of silver. 54 gram of silver. Hagadre, how much electricity they have used? Cross multiply. In baratte 54 by 108. Yes, 2. 1s are 2s are 0.5 or 1 by 2 Faraday. Alva? 1 by 2 Faraday. So that means in this electrolysis reaction, they are utilizing 1 by 2 Faraday or 0.5 or 0.5 Faraday electricity. Aita? Okay, let us keep this one side. Now, the second part of question alli ಏನು ಕೇಳ್ತಾರೆ, how much aluminum will be deposited by the same amount of electric current? Aluminum ನೀವು ಏನೇ ತಗೊಂಡ್ರು, any aluminum salt, aluminum will be in +3 oxidation state. Now, if I want to deposit aluminum, ಏನಾಗಬೇಕು? I have to supply 3 Faraday ಅಲ್ವಾ. 3 + 2 0 ಆಗಬೇಕು ಅಂದರೆ I have to supply 3 Faraday. That means 3 Faraday electricity, if I pass, I can deposit 1 mole of aluminum. 1 mole aluminum weighs how much? 27 gram. 27 gram. 3 Faraday will deposit 27 gram. Now, how much electricity are we passing? We are passing the same. Silver deposit ಮಾಡಕ್ಕೆ we supplied this much electricity alva. We are passing the same amount of electricity over here. That is 1 by 2 Faraday. Then how much aluminum will be deposited? Cross multiply. ಏನಾಗುತ್ತೆ? 27 into 1 by 2. ಇದು division ಆಗುತ್ತೆ. 1 by 3. So this is 3 1s are 3 9s are, right? 9 by 2 andre estu? 4.5. So it is 4.5. Okay, this is how I told you, you don't have to use any formula. Simple calculation. 1 mole reaction baribeku neevu. Adra basis mele find out madbeku. Option B is the correct answer. Okay, so this was different, that's why I solved this question. Option B is the correct one. Understood, right, everybody? Yes? Okay, so I have a very small concept remaining in this chapter, that is batteries and corrosion part. So we shall continue that tomorrow, and I will be starting with aldehyde ketone carboxylic acid. I hope it is done everywhere, or at least it is started. Nippani not started. Okay, what about St. Joseph? Okay, let me started. Okay, Raibach, what about Raibach? Aldehyde ketone. Okay, completed. New PU college. Just started. Fine. It's okay. Starting 2 classes will be very basics, and then when we start with preparation part, I will give you all the reaction. Based on that only you have to answer. Okay, no problem. Anyway, I'll be starting with aldehyde ketone. Okay, please give your feedback. We'll continue in the next class. Okay, have a good day. Bye bye.